Hello and welcome to this episode of Don Labs. In this episode we're going to be talking about capacitors, the different types of capacitors, what they do, how they work, and how to read the values on these capacitors. Now if you'd like to check out my other videos on my channel, I have a video on measuring the capacitors using a multimeter and a component tester, and also how to read and measure resistors. These are very useful as the multiplying system on the resistors is exactly the same as on the capacitors, except there's no colours generally on the capacitors, it is literally just the numbers. So what is a capacitor? As the name suggests, it has the capacity to hold an electric charge, and this is achieved by sandwiching a dielectric material between two conductive plates, and the bigger the surface area of the electric plates, the bigger the charge that can be held. The charge of the capacitor, or Q, is equal to the capacity, C, multiplied by the voltage, V. As you've probably noticed, most capacitors are cylindrical, and therefore you might be wondering, how are these metal plates in a cylindrical object? And that is because they are rolled up into a tube, which increases the surface area but keeping the size small. Now the unit of capacitance is the farad, and it is quite a large unit, so whereas the units of resistance generally go from a magnitude of 1 or 1 ohm, the magnitude of millions, the mega ohm, then farads go the other direction and they generally start with a magnitude of 1, which is a reasonably big capacitor. So 1 millifarad is 1,000th of a farad, 1 microfarad is 1 millionth of a farad, 1 nanofarad is a billionth of a farad, and a picofarad is a trillionth of a farad. So let's start by identifying the different types of capacitors. Now the most common one that you've probably seen are the electrolytic capacitors. Now the types of capacitors are named after their dielectric materials, so electrolytic capacitor is said named because of the electrolytic material used as the dielectric, and they are generally these cylinder looking capacitors, which you've probably seen most of. They come in various different sizes depending on how much current and voltage they need to handle. You also get the SMD type, the surface mount electrolytic capacitors. Now these ones are the easiest ones to read because these ones literally have the value written on the side of the capacitor, and if you turn them round you'll generally see some numbers on there. Okay, so this one is 35 volts and it's 2200 microfarads, and generally electrolytics are polarized. You see the stripe down the side of them indicating the negative side. They have different length of legs, the negative being the shorter. Sometimes you can have different colour stripes. Most of the time this is actually due to the colour of the capacitor. With the surface mount capacitors, the stripe is just denoted by this darkened semicircle. 47 would be 47 microfarads, 5 volts. And as you can see on this one, 220 microfarads, 6 volts. Here we have a variable capacitor, and these are the conductive plates that form the capacitance. And as we turn this wheel on the top, the plates actually move, and that's how the capacitance is adjusted. So that's a good example of how it's actually functioning inside and what's happening. And as you're turning that capacitor, it's unscrewing and reducing the amount of plates that are in contact with each other. Here we have a high voltage AC capacitor. These are generally quite low capacitance. As you can see, this one is 0.47 UF rating on there. This one actually says X2, which means it is actually rated properly for mains. Here we have another very common capacitor type. These two here are ceramic capacitors, probably the next most common that you'll see after the electrolytic capacitors. Now this is where it starts getting a little bit tricky to read the capacitors, as these ones have the coding system which I mentioned at the beginning of the video. that's quite basic. If it's got 2 digits, whatever it says, that's how many picofarads. When the number reaches 100 picofarads, then the coding system comes into play. So this capacitor has 3 digits. Ignore the letter on the end for a second. So we've got 103. So this capacitor is 10 with 3 zeros on the end, which is 10,000 picofarads. So 10,000 picofarads would be the equivalent to 10 nanofarads. So it's just easier to call this by the nanofarads rather than having to write loads of numbers out. And this letter M will denote the tolerance, very similar to the resistors. Instead of having a coloured band, it has a lettering system. And as you can see by the table, an M denotes plus or minus 20%. Usually on capacitors you're only going to see the letters J, K, L, M and N, but the other letters below that are rated as a tolerance of plus or minus picofarads, which you generally don't see. And these are the film capacitors, and they're actually dipped in plastic, so you get this plasticky coating on the capacitor, which is generally how you recognise them. Again, they have the same numbering system on the capacitors. That's a 102J. So we take the 1 and a 0, the 10, we put 2 zeros on the end for the 2, and we get 1,000 picofarads, which is 1 nanofarad. And the J gives us the tolerance of plus or minus 5%. And if we look at this one, 105, so we take the 1 and the 0, we put 5 more zeros on the end of it, so we get 1 million picofarads. And 1 million picofarads is of course 1 microfarad. There are quite a few uses for capacitors. Some of the more common ones are filtering capacitors, decoupling capacitors, smoothing capacitors. As an example, we have an opened up switch mode power supply, and we have a mains voltage coming into the power supply, going through a transformer and coming out as a smaller DC voltage. Now, because we're starting off with an AC supply and we're moving over to a DC supply, we use the capacitors to filter the ripple of the output voltage. So whereas the AC voltage is going up and down, we want the DC voltage to be a smooth straight line. We use the filtering capacitors or smoothing capacitors to do this, as capacitors like to resist the change of voltage, so they smooth out the curves on an alternating current. And they also use quite a lot in timing circuits. You might recognise this as a 555 timer circuit. You actually use capacitors on this to adjust the timing of the circuit, because the size of the capacitor determines how quickly they charge up and discharge, and that information can then be used by, in this case, the 555 timer chip to give a set oscillation or timing. This particular 555 timer circuit has a speaker, so you can audibly hear the change in frequency from changing the capacitors. Don't forget to check out my other videos on the basic components. Don't forget to like and subscribe. Thanks for watching, and don't blow up.